Good morning, friends, and welcome to another episode. In today's class, we'll be looking at naming of compounds. Today, we'll start with simple binary compounds. So, I believe we can start. Now, before we start naming a few compounds, let's try and understand the meaning of the word binary. Binary comes from the word two. So, what it means is that binary compounds are compounds that are made up of two elements. So anytime you have a compound with two elements, it simply means that the binary compound. Let's look at an example. Sodium combined with chlorine is a binary compound. Why? Because it's made up of sodium and chlorine elements. Another example is HCl. This hydrogen and chlorine joined together to form a compound that's also binary. And CaCl2, that's calcium chloride. This is also made up of two elements, so it's also a simple binary compound. Sorry. So we know what simple binary compounds are. They are simply compounds that are made up of two elements. With this, we can start naming a few simple binary compounds. Or let's start with, let's say, sodium, chlorine joined together to form a compound. Now, there are steps involved in naming compounds. So let's look at those steps and we'll apply the steps in subsequent compounds. So the first step. Now, realize that this compound has two main parts. The first part, the second part. In naming binary compounds or simple binary compounds, you start by naming the first part. So first, you need to name the first part of the compound. That's the first thing you need to do. So you name the first part. Let's say this is the first part. You name it. Then the second thing you need to do is to write the oxidation number of the first part. So the oxidation number of the first part of the compound, you write it in parentheses. What I mean by parentheses is brackets. So the second part, you write it in brackets. It's sorry, the first part, the oxidation number, write it in brackets. And please, I'll put asterisk on this one because there are conditions under which you do this. We'll come to that very soon. Then the final step is to write the name of the second part. So you write the name of the second part of the compound. So that's what you put here, the name of the second part of the compound. So the first box will contain the name of the first part of the compound. The second box will contain the oxidation number of the first part of the compound by in parentheses. Remember, the oxidation number in this case will be in Roman numerals. Then in the third box, you'll be writing the third part, the name of the third part of the compound. But once you write the name of the third part, make sure it ends with the height. So it will have to end with height. So let me give you an example. If it is chlorine, then it would have to end with chloride. If it is fluorine, the ending will be fluoride. If it is sulfur, the second part is sulfur, then the ending will be sulfide. If it is iodine, that ending will be iodide. I believe you understand this. Now, with this in mind, let's see if we can name. No, before we even name, let me comment on the condition under which you put the parenthesis. Now, the condition under which you put the parenthesis is this. You use parenthesis with the Roman numeral of the oxidation number inside only when the element in the first part you are dealing with has variable oxidation state. There are some elements that have variable oxidation state. I remember when we were looking at oxidation numbers, we looked at some elements with variable oxidation state. Example, sulfur is an element that has variable oxidation state. Another example is iron. It has variable oxidation state. Another example is zinc, copper. All of these elements have variable oxidation state. So normally when you are dealing with a binary compound with the first element being an element with a variable oxidation state, what it means that you have to bring the parenthesis and write the oxidation state of that element in that parenthesis. However, when you are dealing with an element whose oxidation state is fixed, like sodium, sodium has a fixed oxidation state. Potassium, another example, it has a fixed oxidation state. You do not need to bother with this step. You just need to ignore it. So you need do the first step and the third step. The parenthesis step is not important. So let's look at some examples. So we start with sodium, this compound. This compound, so the first part we name it, so the first part is sodium. Now the question is, do we bring a parenthesis in this case? The answer is no. And it is no because sodium has a fixed oxidation state. So we do not need to bring a parenthesis. We just need to go straight away to the chlorine and name the chlorine in its chloride form. So the chlorine will now be chloride. That's how you name this compound. It's sodium chloride. Let's look at another example. So we'll do K2S. So let's name this. So you name the first part, parenthesis, then the second part. So the first part is what? Potassium. Question is, do we need to bring parenthesis? Here too in this case, no, because potassium has a fixed oxidation state. In fact, potassium is in group 1. Group 1 element would always have fixed oxidation state of 1. So you don't need the parenthesis. So what you need to do is to move straight away to the sulfur. So it will be sulfur, but it will end in its hide form. So it will be sulfide. So that's how you do this. Let's look at another example. So in this example, we'll be looking at CO2. So we first name the carbon, then we name this one. So we start with carbon. In this case, do we need a parenthesis? Yes. Why? Because carbon is one of the elements that has different oxidation states. So what it means is that we will need to calculate the oxidation state of the carbon in this compound. You put it in this parenthesis before we can proceed with the naming of the compound. So let's calculate the oxidation state of carbon. You know how to do this. Please, if you've forgotten to do this, you need to go and refer to how to calculate the oxidation numbers of elements in compound. There was a video we created like that for you. So now let's calculate the oxidation number of carbon in this compound. So that will be carbon plus 2 times of the oxygen equals to the charge on the compound is 0. So what it means that the carbon will be plus charge of oxygen is -2, so that will be 2 times -2 equals to 0. So that will give us C minus 4 equals to 0. So what will be the oxidation number of carbon? It will be C equals to +4. +4. In Roman numeral format, that will be IV. So what it means that we have to put IV into this parenthesis. or this bracket. And you can continue with the oxygen, the next level. So the oxygen is no more going to be oxygen, but it will be what? Oxide. So that's carbon 4 oxide with the oxidation state of the carbon showing. Let's look at another example. So here we have CO, and we are to name this compound. Of course, we name the first part then the second part. The first part is still carbon. But carbon we know has variable oxidation state. So we need to calculate the oxidation state of this particular carbon in the compound. So let's do that quickly and put that in the parentheses before we can proceed. So the charge on this compound is 0, okay, and is equals to that algebraic sum. So carbon plus oxygen, right? So that will be carbon, the charge on oxygen is -2 equals to 0. So what it means that the charge of the carbon in this compound will be +2. So what it means is that the parenthesis will be II. So put II there. So that will be oxide. Simple as that. Let's look at another example. So let's take an example like copper. And so you take CuO. So we name this compound. So here we name this first, then this, by in between them there will be a parenthesis. That depends on whether copper has a variable oxidation state or not. So the naming will start with copper. The question is, do we go for a parenthesis? And the answer is yes. Why? Because copper has variable oxidation state. What it means that we need to calculate the oxidation state of the copper. So let's do that. So that will be Cu plus the oxygen equals to the charge on the compound is 0. So Cu, the oxygen is -2, so equals to 0. So Cu equals to +2. So the oxidation state of the copper here is II, 2. Put it there. So copper 2 oxide. Simple as that. Let's look at another example. So this time we'll take Cu, then make it S. Okay, so here too it will be copper. Copper, because it has a variable oxidation state, we need to calculate the oxidation number. Then our sulfide, remember that. So let's calculate the oxidation number of the copper. So that will be Cu plus S equals to the charge on the compound is 0. Cu, the charge on the sulfur is -2. So that will be 0. So if you want copper, copper will give us +2. This is II. So copper 2 oxide. As simple as that. Maybe we'll be looking at the final example, and with this example, let me see if I can come up. Let's use zinc. So we do zinc Cl. So that means that the naming of this compound will be zinc. Does zinc have a variable oxidation state? Yes, so there will be a bracket. Then our chloride. We need to calculate the oxidation state of the zinc. So here it will be zinc plus chlorine equals to the charge on the compound is is 0. So zinc charge on chlorine is usually -1. It's a group 7 element, an halogen. They always have charge of -1. That will be equals to 0. So if you want a charge on the zinc, it will be equals to +1. So the zinc is 1. We'll put zinc 1 chloride. It's as simple as that. So remember, in any binary compound, the steps you are supposed to follow is to first name the first part of the compound, followed by the parenthesis. That is, if the first part of the compound has a variable oxidation state. If the first part of the compound does not have a variable oxidation state, you do not need the parenthesis. Then the next step is to go into the second part of the compound and you name it in its ide form. If it's chlorine, it will be chloride. If it's sulfur, it will be sulfide, and it will go on like that. Please, that's how you name simple binary compounds. Simple as that. Thank you for watching. Please subscribe to the channel if you've not done so. Share the video with your friends who are struggling in science. We'll meet again. Take good care of yourselves. Bye.